Okay, so in this video, I want to go for a specific kind of lens. Now, this lens is called a convex lens, or sometimes called a converging lens. Now, what this does is it converges light rays through the focal point. So let's draw a diagram to see what I mean by this. So first of all, we're going to start off by drawing something called the principal axis. Next, let's draw the lens at the center of this line. Now, a convex lens is thin at the edges and it gets wider at the center. So let's draw something like that. So that's my convex lens. Now, what I'm going to have is an observer. So let's draw someone's eye looking through the lens at an object. And let's say this object is a person. Okay. Now, the distance from the object, so let's label that object, from the lens is what we call the object distance. And that's always labeled as U. So we've got U is our object distance. Okay, now each lens has its own focal point. And this is the point that light rays get refracted through. So that's our focal point, and we'll label it F. Now it's a property of that individual lens, so you can have a focal point on either side. So we've got F is our focal point. And then the distance between the focal point and the center of the lens is what we call the focal length. I'll just give that a lowercase f, so focal length. Okay, so in order to sketch a ray diagram, we need two rays. So the first ray that we need is we need a parallel ray. Now that parallel ray goes from the object. So we've got, let's say it's from the person's head. So it reaches the lens. Now the parallel ray gets refracted through the focal point. So as it meets the lens, it gets bent and it travels through the focal point. Okay, so you've got a parallel ray that gets refracted through focal point. And then we need a second ray. Now our second ray passes through the center of the lens and it goes through unrefracted. So let's say we want to find where the person's head is going to be after passing through the lens. We draw a straight line passing through the center of the lens and it's completely unrefracted. Okay. So ray 2 is a ray passing through the center. And this gets unrefracted. Okay, so where these two rays meet is where the new image will be formed. Now, these light rays are both from the top of the person's head. So that's where the top of the person's head will be. Now, if I then carry on and draw a ray, let's say from the person's shoulders, it's going to go through, meet the center of the lens, get refracted through the focal point because that's my parallel ray. Let's draw a second ray from the exact same point going through the center. Now it's going to be completely unrefracted. We get a new point here, and that's where the person's body will be formed. Okay, if you do that multiple times, you get the object. So we start tracing out our object. Now if I drew this accurately, that should have been on the person's waist here, or sorry, on their shoulders. Okay. Sometimes this is represented using an arrow instead. So we get the tip of the arrow formed here and this arrow here. So we can see that we formed an inverted image. Now the distance between the image formed, so let's label that image, and the center of the lens is what we call the image distance, and we'll label that V. So that's our image distance. Okay, so let's just rub out some lines that we don't need. Okay, so that's our ray diagram.